Okay, number 22 I would consider to be a pretty upper level question here. If you're going to get a 5 out of 5 on this test, then you need to know how to do this. If you're okay with the 3 or something, then don't sweat this one. But here it is. An equation for a function is shown. And again, anytime you have a quadratic equation given to you, you should look at it. You should look at it. And if you want to be able to look at this equation, you need to be able to type it into your technology. And so what you need to know is instead of calling this y of t, just call it a y. And instead of the variable t, you're going to have to use x, because these are the variables that are used with that online graphing calculator. So in my online calculator, let's go type the equation y equals negative x squared plus 14x minus 40. All right, let's put that into the technology calculator that we have access to. Negative x squared plus 14x minus 40. So negative x squared plus 14x minus 40. There you go, double check that. All right, looks good. All right, so let's take a look at this. Look at this graph. All right, you can barely see it. You can barely see it, but I see a piece of it. What I'm going to do, you could zoom in and zoom out, but what I'm going to do is I'm instead of zooming in and out. As soon as you zoom in and out, then you can't use the window feature to adjust the window. So I'm not going to zoom in and out. I'm going to look at the table and see what kind of values I need to include on this if I want to get a good picture of this. And I see what's happening is my x values go from negative 5 to negative 1. My y values are going from negative 135 to negative 112. Let's see. If I go back a page, you just keep getting further down. So let me see if this thing will. I think I need to go from 0. You guys won't know this. Let's go to the graph. All right, let's just go ahead and scroll over and see what we see. Okay, looks to me, there we go. And then I'm just going to zoom out. Let's just look at this. Okay, this is pretty decent. Let's go up. Okay, this gives me a pretty good idea. All right, look what this graph is doing. It's a quadratic graph. It's got intercepts at 4 and 10. It has, looks to me like a maximum right here at maybe lining up with 7 on my x-axis. And so if I look back at this problem here, it says the value of y of t increases over the interval 6 is less than or equal to t is less than or equal to 7. So here's what this means. Along the t-axis, which remember we're using x for this, from 6 to 7, this statement says that the value of y of t increases. This means the curve is increasing, or the graph is increasing. Over that interval. So let's go see if this looks true. Is the graph increasing as we go along the x-axis from 6 to 7? All right, if I go from 6 to 7, I would say that's this little section here. It looks to me like it's increasing between 6 seconds and 7 seconds. All right, here was 6. Here was 7. I'm going to say that on this interval here, yes. It looks like the graph is increasing. So let's go back over here and choose this one as a yes. Good. How about this? It increases over the interval from 7 to 8 seconds. So let's look at the graph from 7 to 8 seconds. All right, from 7 to 8 seconds, here's 7, here's 8. that would be this section here. Does this look like the graph is increasing? Okay. When you talk about increase or decrease, I'm going to remind you this. Always trace the graph from left to right. You're trying to determine whether the graph is increasing or decreasing. So when I go from left to right between 7 seconds and 8 seconds, this graph is not increasing anymore. It's turned around and it's decreasing. So this is a no. Okay, the next statement says that the average rate of change over the interval from 6 to 8 seconds is 0. The average rate of change, that means the slope. Average rate of change is fancy for the slope between 6 and 8. Between t equals 6 and t equals 8. Or in this case, I guess it's x equals 6 and x equals 8. So let's look at that interval from 6 seconds to 8 seconds. Okay, well here's what we just saw. Was at 6 seconds, we were here. And at 8 seconds, we were here. And so the overall, although we did increase and we did decrease, overall, between those 2 points, it's horizontal. And you know what horizontal means? It means that the slope is 0, or the rate of change, average rate of change is 0. And so that statement that said the average rate of change over the interval 6 is less than or equal to t is less than or equal to 8, okay, between 6 and 8 seconds, the average rate of change is 0. The slope is horizontal. That's what a slope of 0 means. And that's a yes, it was. Between those two, from the start of the interval to the end, there was a net gain of nothing. It was flat. All right, the next choice, the value is constant over that interval. All right, well, the value is not constant. No. Okay, it increases, the value increases, and then it decreases. So it's not that it stayed constant that whole interval. It increased and decreased. It's just that it started at the same point and ended at the same point. So that's not true. And then the last one says that the average rate of change on the interval from 6 to 7 is the same as the average rate of change on the interval from 7 to 8. Well, we looked at this graph enough times to know that from 6 to 7 seconds, the average rate of change was positive because the graph is increasing. But from 7 to 8 seconds, the average rate of change was negative because the graph was decreasing. Okay, so again, to answer this question without the graph would be absolutely out of the question. But looking at that graph, again, let me just sketch it here. So you can put this on there on your notes. Okay, what we've been looking at is, again, intercepts at 4 and 10, a maximum value of 7. So this was the graph. Oops, I didn't mean to put a 7 there. There we go. All right, so this was the graph. And what we were looking at was between 6 and 7, and then between 7 and 8. And so that final statement that says that the average rate of change is the same, it's not the same, okay? They're opposites. They're reflections of each other, but they're not the same rate of change. So I think the first and the third are the only ones that you should select for number 22.